A hyperbolic path is modeled by 6 secant t equals x and 10 tangent t equals y. So these are determining our x and our y value. So what we can do is figure out the derivative of x with respect to t, which again is saying how does a small change in t affect x, right? That's what we're really looking at, small change in x and small change in t and how they're related. So we get dx dt, derivative of x with respect to t. We get 6 times the derivative of secant t is secant t tangent t. Okay, dy dt is 10 times the derivative of tangent, which is secant squared t. So then this is a change in y with respect to t, change in x with respect to t. If we want our change in y with respect to x, we have to divide them. And when we do that, the dt's are going to cancel. So we get 10 secant squared, or dy dt, over 6 secant tangent. Okay, we have a secant on top, we have a secant on bottom. So one of the secants on top, since it's secant squared, will cancel with the secant on bottom. So now we have 10 secant equals 6 tangents, or 10 secant divided by 10 tangent. So then we can say, well, 10 secant's just 10 over cosine, since secant's the reciprocal of cosine. And 6 tangent is just 6 tangent, or sorry, 6 sine over cosine. So then to divide fractions, we can always just copy dot flip, copy switch flip, whatever you want to say. So we could have cosine over 6 sine. Okay, so we just copy switch flip to do this. And then, oh, the cosines are going to cancel. So we get 10 over 6 sine, which is 5 over 3 sine. And then sine is the reciprocal of cosecant. So if we want to clean this up a little bit, we could say this is 5/3 cosecant t. And that is our dy dx with respect to time. So before, when we found dy dx, like in number 6, that was with respect to y and x, in terms of y and x. But now our slope is in terms of our t value, which is determining our x and our y value. Okay, so same idea, but different method for finding them.